So we have learned that what is matter, what is atom, what is molecule, what is substance, what is compound, like many different words we learned. Let me tell you once again what are these words meaning. Number one, substance. What is substance? Substance is made of elements. You can say compound also. And of course, compound also have the same meaning, made of elements. So substance, compound you can use alternatively. Now, element made of molecules, molecule made of atoms. So when you're going from substance to molecule, molecules to atom, of course I'll write another point here for your understanding. Atom, what it is made of? Is that correct? Made of particles. So when you move from substance to atom, the size of the entity decreases. Today we know that the smallest thing existing in the universe is particle, like electron, proton, neutrons. So substance, compounds, these are mixing of elements. For example, if you take elements, compounds example, I can say H2O is a compound, and NaOH is a compound. Mixing of different elements. Elements is made of molecules, say iron, zinc, etc. Copper, aluminium, all examples comes under elements. Molecules, of course, again you can say hydrogen molecule, oxygen molecule, nitrogen molecule, like that. All the molecules. Now atoms, yes, atoms means hydrogen atom, oxygen atom, nitrogen atom, sulfur atom. So what I want to make you to understand that combination of atoms you get molecule, combination of molecules you get compounds and substances, and combination of elements also you will get compounds. If you see this iron and zinc, aluminium, these type of elements have single atom. They have single atoms. Now take the example of hydrogen, oxygen, nitrogen. Okay, you can tell me how many atoms are existing. Yes, they exist. They are having 2 atoms. And if you take the compounds, compound like H2O, CuSO4, copper sulfate, etc., they have got different atoms. So my point of explaining that in nature we have single atom substances, dual atom substances, different atom substances. Yes, 3 similar atom substances also existing, and all these elements and molecules combine together to give different types of compounds to us in the nature. We have different elements in nature. I can say iron, zinc, copper, aluminium, like many elements are there. But how would you recognize an element internationally? Throughout the world, the different people in different countries should say a single name to a particular element. Is it possible? Is it necessary? And I will say that yes, it is necessary. If you do not have a unique name internationally, then you can't communicate with the other people in the outside of our country. Suppose think that if you have a name for gold, gold is English word, but in your mother tongue you may have a different name, and you don't know what is the name, international English name for the gold. Then see how much of difficulty you feel. So if you want to express the same thing what they want to express, but there is a communication gap, because you are saying gold, one person says gold in English and some other person saying in Hindi sona, some other person saying in their mother tongue. All three are communicating the same thing, but they don't know what they are saying. So that's why scientists had thought like this. They have the vision and they understand that they will get a problem like this. So they have given common names to the elements, so that whatever be the language, whatever be the nation, they should uniquely identify the element. And based on those names, and today we have periodic table in chemistry. So let me tell you some names for the elements. So naming of elements. First I will write the elements, then we will write the symbols. Hydrogen. Meanwhile, you open your book and try to write the symbols for these elements. Oxygen, nitrogen, sulfur, carbon, calcium, chlorine, chromium, boron, barium, bromine, beryllium, aluminium, iron. You're following? Yes? Okay. Gold, sodium, potassium. Right, so these are the elements, and next to element you have to write the symbols. Some scientists told that why didn't you write the capital letters to all the elements? Then again they understand that while they are writing the chemical reaction of a particular elements, it will take long time to write full names in capital letters. Then some scientists suggested to take the first letter and it in the capital letter. So they started giving the names. Hydrogen first letter H, so capital letter H. Oxygen first letter O, so capital O. Nitrogen first letter is N, capital N. Sulfur first letter S, so capital S. Carbon, you are correct, capital C. Coming to calcium, first letter capital C. There comes the problem. Because carbon is also having symbol C, calcium also symbol C, means there is a confusion. Then the scientist told that take the second letter also. But see that second letter is in small case. So in the calcium, the second letter A, so Ca. And chlorine, Cl. Now here onwards, you can't say that a rule satisfied for all the elements. Like the second letters H I can take as I can write CH. It's not possible because of it is having problem with the other elements. Sometimes they have taken some another letter in that word. So chromium, Cr, boron, B, barium, Ba, bromine, Br, beryllium, Be, aluminium, Al. Now iron, Fe. See, iron is not I, because I already given to some another element, and some elements have some another chemical names, or based on names they have taken the symbols. Iron, Fe, gold, Au, sodium, Na, potassium, K. So if you want to know more about this chemical symbols, everything, I am suggesting you to follow and observe the periodic table. So we understand how to give the symbols for the elements, but sometimes some elements have more than one atom. Now how do you represent? Take an example. Hydrogen. Hydrogen has got two atoms. It has got two atoms. Now how do you represent? Do you say that a hydrogen symbol is H, as we discussed earlier, so the symbol is 2H? This is wrong. 2H says that like 2 times of hydrogen. Is not correct. So then scientists have another idea. They told that how many number of atoms you have, take it as subscript for the symbol of the element. Like this is the symbol for the hydrogen and subscript is like this, you have to write, and this is correct. Similarly, if you take oxygen, like it has 2 atoms, so the right way of writing is O2. You take ozone layer. Ozone layer is in the atmosphere. It is protecting us from the harmful radiations coming from the sun. Ozone, it has 3 atoms. So you can write O3. So in that way, the number of atoms what it has, take that number as a subscript for the element, and you can write. Right. So let me tell you another concept called atomicity. What is atomicity? Already you know this, but we are giving a specific name to the thing what you know. Atomicity is nothing but number of atoms in an element. That is atomicity. For example, hydrogen. How many atoms are there? 2. So its atomicity is 2. Ozone, O3. What is the atomicity? Tell me. Yes, you are correct. It is 3. Like that, atomicity we have single atom, monoatomic, 2 atoms, diatomic, 3 atoms, triatomic, 4 atoms, quadratomic. Like that, we have so many elements which are having 1, 2, 3, 5, 6, 7, like different types number of atoms. Now, I will give a table here to know that the different monatomics, diatomics, and more than 3-4 atoms of elements. Argon. Here I am writing atomicity. Right. Helium, sodium, hydrogen, nitrogen, chlorine, so phosphorus and sulfur. Let me tell you the atomicity of different elements, but I think you know all this thing because already we discussed this. Now quickly write down. Argon, Ar. So argon, Ar, its atomicity is 1, so it is monoatomic. Monoatomic. Mono means single, number 1. Helium, He, it is also monoatomic, number 1, 1 atom exists. Sodium, again 1 atom, monoatomic. Hydrogen, see hydrogen atomicity is 2, so it is diatomic. It is diatomic, di means 2. Nitrogen, N2, 2 atoms, So again it is diatomic. Diatomic. Chlorine, Cl2. Yes, what is this? Yes, you are correct. Diatomic. Right. Now, ozone, already discussed. Ozone, O3, it is triatomic. 3, na? 3 means tri. Triatomic. Phosphorus, P, it is having 4 atoms. 4 means tetra. Tetraatomic. Sulfur, yes, 8. Double to phosphorus. So it is octoatomic. Octo means 8. Like that, different elements have different number of substances. Next concept, valency. Valency means, you know that in different chemistry chapters we learned that valence is number of atoms existing in the valency orbit. We know about valency in different chemistry chapters we learned. Valency is number of electrons existing in the outermost orbit. So what is the significance of this number of electrons in outermost orbit? Because they are important. They are important because they will combine with another element to make a compound. Each and every orbit wants to get a stable state, but when the electrons are not exactly located with a perfect number, they are unstable. When they are unstable, they want to combine with another element to make a stable compound. So here the valency means the combining capacity. The combining capacity of an element. Same thing. The combining capacity only comes with based on the number of electrons existing in the outermost orbit. Let me give some examples of some elements and their valency strength. Element and valency. Let me write the element names. Hydrogen, carbon, chlorine, helium, argon, fluorine. Now hydrogen is 1 valency, carbon is 4, oxygen have written, chlorine is 1, helium is 0, argon is 0 and fluorine is 1. So this is what the valency of the elements, which shows interest to combine with the other elements to make a compound. We have understand that to make a compound we have to combine the elements. Sometimes we combine the elements of similar type, sometimes combine elements of dissimilar type to get the compounds. For example, if you want to have oxygen molecule, you're combining two oxygen atoms. Suppose you want a compound of copper sulfate, of course you are combining two dissimilar elements like copper and sulfate. Now let me tell you another type of combination. This combination is not done by atoms directly. This combination is done by charged species. Charged species means these are the atoms having some charge. Because of the charge, either they attract or they repel. Generally, to make a combination, the charged species should attract each other. Then only they mix together make a compound. So in that way, we have two types of charges. One is positive charge and second one is negative charge. So these charged species technically, chemically are called ions. So ions are the atoms which are having some charge, and because of the charge they do some chemical reaction which is called ionic reaction and they make a compound. Let me tell you an example. Take a sodium chloride. Sodium chloride compound. It is a mixture of sodium and chlorine. As you know that. Here, they are not combined in normal chemical reaction. They are combined using charged chemical reactions. This is called ionic reaction. Sodium has a sign, plus sign, on the top of it. What is plus sign represents? The plus sign represents that the sodium is having positive charge. And the positive charged ions are called, cations. Cations. So cations means positive charged ions. Remember the technical names because very important in chemistry. You have to use frequently, regularly these words. And chlorine has negative sign. Negative sign means negative charge. And this is called anion. It is called negatively charged ions. So negatively charged ion is anion, positive charged ion is cation. So this positive charge, negative both combined, Na plus and Cl minus combined to give sodium chloride compound. Now, if you ask me that what is the valency of these ions, I will tell you. See, valency of the ions is nothing but the magnitude of the charge. For example, what is the valency of Na plus? What is the charge? Plus. Plus means plus 1. So its valency is plus 1, magnitude of the charge, or simply you can write 1. Now coming to valency of the chlorine. So the charge is minus 1. What is the magnitude? 1. So the valency of chlorine is again 1. Suppose if you ask what is the valency of sulfate? SO4 minus 2. What is the valence of sulfate? So the quick answer is 2. In that way, the magnitude of the charge of the ions is the valency. Here, I am showing a table to you to understand that ions having different charges. It is not that ions always having single unit. They have plus 2 charge or minus 2 charge. They have plus 3 charge or minus 3 charge based on the chemical compositions we do. So as you see in the table, let's try to write down the symbols and their units of charge. Sodium is Na and sodium is cation. If this column is a cation, cation is positive charge ion, anion negative charge ion. So it is Na plus means plus 1. Hybrid H minus 1, or you can simply write H minus. Potassium K plus. Chloride Cl minus. Silver Ag plus. Bromide B minus. So these are the single unit cations and anions. Now see this table, this row, 2 units means 2 charge. Magnesium Mg plus 2, so you have to write a number. Calcium Ca plus 2, zinc Zn plus 2. See the anions, oxide O minus 2, sulfide S minus 2, sulfate SO4 minus 2. This is 3 units charge. Aluminium Al plus 3, iron Fe plus 3, nitrate N minus 3, phosphate PO4 minus 3. PO4 minus 3 means whole PO4, like sulfate also whole sulfate. So in that way, these cations and anions are combined with their valencies and will give compounds to us.